Okay, first we'll talk about even and odd functions in general, what properties they satisfy, and then we'll look at a couple examples. So, f is an even function if, when you plug in negative x to the function, you get the same thing as if you plugged in x for the function. Okay? So, f of negative x equals the original function f of x. That's important to be an even function. F is an odd function, and these are not like even and odd numbers, okay? These definitions apply to functions. F is odd if, when you plug in negative x to the function, you get the opposite of the original function. So here, you get the original function back when you look at f of negative x, and here, you get the opposite of the original function, meaning multiplied by -1. Okay? Not every function satisfies one of these two properties. Some functions satisfy neither one. So there are some functions that are not even and also are not odd. Similar to numbers, right? Not every number is even or odd. The number 1/2 is not even and it's not odd. Okay? So an example of, let's look at an even function first. Maybe the most common example of an even function is f of x equals x squared. And the reason it's an even function is not, it is because of the even exponent, but it's an even function because it satisfies this property. Okay? So f of negative x is what we're interested in. And if we look at that, we get negative x quantity squared, right? Plug in a negative x everywhere there's an x. And what happens is, because this is an even exponent, when you square the negative, it becomes a positive and you just get x squared. So f of negative x equals the original function f of x. So it's an even function. A good example of an odd function is f of x equals x cubed. If you look at f of negative x, you get negative x quantity cubed. And now when you cube the negative, you get a -1. When you cube the x, you get x cubed. And notice the difference between these two. Negative x quantity cubed means you're cubing negative x. Negative x cubed means you're cubing the x and then taking the opposite of it. So f of negative x is the opposite of the original function f of x. So this is an odd function. Okay? Another important property to look at with even and odd functions are their graphs. So let's take the first one here, f of x equals x squared, which we know is a parabola. Looks something like this. Okay? Parabola, vertex at the origin. If you plug in x, here's x. Well, if that's x, negative x is over here, the same distance from the origin. An even function, f of x is the same as f of negative x. That means the y values for these two x values are the same. So this y value is up here. This y value is also up here. So see how they have the same y value. So what that means is when you plug in an input and its opposite, you'll get the same y values, and you'll get a nice symmetry around the y-axis. Let's look at the graphical properties of an odd function. F of x equals x cubed is similar to x squared. Oops. When x is positive, sorry about that. It curves up to the right. And when x is negative, it curves down now instead of back up. So over here, if you look at x, let's say this is x, then negative x has to be right here, of course. The y value for x is here. The y value for negative x is here. So you see how one y value is positive and one y value is negative, but they're the same distance from the origin. So now the y values are opposites of each other for opposite inputs. Okay? So another way to say this is those points are symmetric about the origin, meaning if you reflect this point over the y-axis, you'll get this point, and then reflect it over the x-axis, then you'll get this point. So it's two reflections now to get your symmetry.